Papa Flammy's Advent Calendar.
Good morning, fellow mathematicians. Welcome back to another video on the Advent Calendar. Two things before we get started. I'm feeling quite terrible right at the end of the Advent Calendar. I still need to record a bunch of videos, but I caught some kind of cold. I'm feeling kind of wasted, but I'm still trying my best to get everything finished. Also, this video has been sponsored by the amazing people over on Brilliant. Make sure to go over to their services and check them out. They are amazing, and maybe this is going to make for an awesome Christmas present for your loved ones and STEM-interested friends. And now we are going to dive right in. Now, I thought I was done with the parabola saga here on this channel, but I remembered something. Back at university, when I had my praxis semester, this was the last semester in my studies, and it basically was working at a school for half a year. I formulated my first ever exam. It was on quadratic functions, and this exam was the culmination of 3 months of teaching in a 9th grade at a gymnasium. Gymnasium is like the highest school form that you can go into. So it's a 9th grade exam, and they had 90 minutes of time for it. Now those 90 minutes were split into 2 parts. As usual, the first part was without support materials, no calculator, no Tafelwerk, so formula sheet and the like. 20 minutes, they got time for that. If they were done earlier, they could bring the solutions to my desk, and then they could have the second part. Second part was the other 70 minutes that were still left, maximum time. And this is what you're also going to see in the PDF documents. You can download, as always, links are in the description, the roughly translated English version and also the original German version. And I don't want to waste too much time on the introduction. I think the exam is quite okay for what it was back in the days in 2019. It was my first exam ever designed, so it's totally not perfect, most definitely not. But I think for a first attempt, it was quite fine. What is bugging me though is how it was formatted, basically. It just is not to my appeal. It's not far from what I do now after a bunch of years of experience, but for some reasons a bunch of things were bugging me, and I didn't change them in the English version. I left it as is, and that's good. It was what it was, but now I'm way better at designing exams when it comes to the formatting. So yeah, this is basically all I wanted to say. So just to conclude everything, 9th grade, 90 minutes of time, everything on quadratic functions and the like, and a bunch of just basic stuff that they need to know in part 1. And now we're going to go over to the blackboard, and I would love for you to comment down there below what you think of the exam. Is it good? Is it not good? What do you think about it? What would you change if you were in my position, for example? We are going to go ahead and get started, and I hope you are going to enjoy the solutions, and I hope I'm not going to freak anything up because of my throat. I haven't formulated any solutions. I don't have the solutions lying around anymore. That's totally improvised, but it should be doable, I guess. It was for the students, so it should for me too. Let's go. All right, let's not waste any time. Let's go ahead and get started. First part, no support materials allowed, 20 minutes. Yeah, the questions on the somewhere on the screen. Given are the properties of a parabola. For each one, name an equation satisfying said property. And I'm going to go with the easiest solutions, at least in my book. As mentioned before, I just roughly translated it. I didn't have any kind of Erwartungshorizont, so solutions lying around. So let's just improvise it a bit. So the first one, a parabola which is neither stretched nor shrunk. That overall means that it doesn't have a stretching factor. It's basically monic. So that means I'm going to go with f of x is equal to x squared. It's just a parent function. Now for the next one, be a monic parabola, just like this one, that is shifted in the positive x direction. So the only thing that we really need to change here is we need to have a shifting factor. So that must be x and let's say minus 2, for example, squared. It's shifted in the positive x direction. A parabola that is stretched and opened at the bottom. Open at the bottom means that it's just basically having a negative sign at the very front. So we have f of x is equal to negative, and it's stretched, so 2 times x squared. Okay, a monic parabola that is shifted in the negative x and positive y direction. Okay, so we have two conditions here. So at first what we need is we need an x here, and we also have into the positive y direction, so +1 for example, and in the negative x direction, so we have +69 for example here. That should do it. And the e, a parabola which is opened in the downwards y direction, so just like here, and is neither shrunk nor stretched. This just screams for the parent function, but with a negative sign in front. That's the easiest solution, I guess. And the parabola with its vertex lying in the fourth quadrant. So fourth quadrant means it's shifted into the positive x direction and the negative y direction. So we can just use this one, but with a negative sign. So f of x is equal to x minus 420, for example, squared. -1, for example. Okay, yeah, fourth quadrant. Okay, that should work out. That was the first exercise. It's just here to have basically a bit of basic knowledge to be asked. Okay, next one. A plushie costs 20 euros on release. After some time, the price is reduced by 10%. More time has passed, and the remaining plushies will now be sold at an additional 20% off. And the first thing to do is we need to calculate how much the remaining plushies actually are. So this is number 2. We start with 20 euros. And the 20 euros, they are basically 100% with dimensions. So what we are asking, what happens after a reduction of 10%. So this gives us 90% basically. How many euros are there? So we all know how to reduce using percentages. We are just going to multiply the 20 euros by 0.9, which is the same as 90% divided by 100%. And this should give us 18 euros. Okay, easy enough. And now they are going to be reduced by an additional 20%. So that means we are going to go through the same thing. But now our 18 euros are our new 100% overall. So what we are going to do is we are going to multiply the 18 euros by 0.8 because they are now 80% of the original price, meaning overall what we're going to get, 20% of 18 euros are 360, no scope for 20 places, meaning we are going to get 1440 here, I guess. Yeah. And now we also need to calculate if we calculate additionally the percentage by which the toys have been reduced in total. This is obviously a funnel question that mathematics teachers like to ask, because people say, well, 10% first and 20% obviously, 30% no. It's obviously something else. So what you basically need to do is you need to say, well, 20 euros were the original 100%. So how many percent are the 1440? So what's basically going to happen is we are going to divide the 1440 by 20 euros basically, and then times 100. This is basically what we are going to get here, and we can play around with the numbers a tiny little bit. So if you were to half all of this, do we need to reduce it? I mean, basically this is already the answer times 100%, and then you are going to get the answer out that you basically need. Let us try to do some algebra here, some mental calculations just for the heck of it. I would already think of this as a final answer that would be completely fine in my book. 1440 divided by 2 would be around 720. So this right here is 72, so 28% reduction. No, that doesn't seem right. 28%. Let me think for it. No, yeah, 28%, I think, right? I mean, 25% of the original one would be, yeah, that would be 5 euros. Yeah, so that probably checks out 28%. As mentioned before, this right here would be a valid answer for me as a teacher. I would be fine with that. Third exercise. 1 kilogram of apples costs 6 euros. How much are 2.3 kilograms? I mean, this is just making use of cross multiplication here once again. So we have 1 kilogram corresponds to 6 euros. So we are going to ask ourselves, how many kilograms do we go for blah, blah, blah euros? So 2.3 kilograms. So you just cross multiply. So you are going to get overall that 6 zeros times 2.3 kilograms divided by 1 kilogram is what? Kilograms is going to cancel out. Dimension-wise, 6 times 2.3 is going to be 13.8, right? So we get 13.80 euros overall. And a bonus question here. Formulate the equation of a linear function describing the price with respect to the mass of the bought fruit. If possible, determine the zero of the function. Obviously, if you don't buy any fruit, then you don't buy any fruit. Obviously, okay? So if you don't have any apples, then you don't pay anything. This is just how apples work, apple algebra. So meaning this right here is just a linear function because the price acts linear. The more, but in a linear way, obviously. And our price raises by 6 euros per kilogram. So if this right here is a function with respect to the mass that we basically have, you could say, then we are going to get 6 euros times m. This is basically everything. It's just linear scaling factor. And the zero of the function obviously is going to be at 0 because it's just a proportional function. Okay, I think this should do the trick. Now for the fourth exercise, we have given 9 to the 8th power is equal to 25, and they have to determine what 3 to the 8th power is. And I mean, it's kind of obvious, at least to us, but for the students, this right here was probably pure horror because a in an exponent. So 9 is nothing other than 3 squared. So this right here is the same as 3 squared to the 8th power, but we know exponentiation rules. This is the same as 3 to the 2a. Or if you want to bring it into the form 3 to the a, then we can use exponentiation rules once again to turn this into 3 to the a squared is equal to 25. And now what we can do is we can take the square root, and we are going to get that 3 to the a is equal to just positive 5 because we have a positive base here. So we don't have any complex solutions. They are just 9th grade. I think this should do the trick. I hope everything else was right. At least I think so. And now solve the following inequalities for x. Now the first one that we have is that x is greater or equal to 2x plus 1. And now we are just going to regularly solve it. We are going to subtract x on both sides, just like regular equations. We are going to get that 0 is greater or equal to x plus 1, meaning we are going to get that if we were to subtract 1, that x is less or equal to a negative 1. Yes, obviously. Okay, next one. What do we have? X squared is strictly less than x squared minus x plus 3.5. Once again, just like before, subtracting x squared on both sides, we are going to reduce this to a linear inequality. So 0 is less than negative x plus 3.5. And then adding x on both sides, we are going to get that x is less than 3.5. Okay, next up we have negative x is greater than negative 12. This right here is the first part where they really need to think about how inequalities work once you solve for x. If you were to multiply by negative 1, the order relation is going to shift around. And if you think about this in numbers, it does make total sense. So x is less than 12. Because if x, for example, is 3, then we have negative 3 is greater than negative 12, for example. This is how it works out. And if you then take the negative sign away, then we would have that 3 is obviously less than 12. So this is how it checks out. And the last one is 1 plus x divided by x is less or equal to 14. No, here it turns around. It must be less or equal to 12, right? Yeah. Yes, exactly. And other than that, how you could multiply by x, but then I would need to think about the order relation. I'm going to break this fraction up. I think this is a better way right here. So we are going to get 1 over x plus 1 is less or equal to negative 14. It is negative 14. And now we subtract 1 on both sides, giving us that 1 over x is less or equal to negative 15. And now we take the reciprocal on both sides, and this should turn around our order relation once again. So x is strictly greater than negative 1 over 15. Think this should do the trick. If I plug in numbers, we have, for example, x as negative 3, for example, then this would work out. Then, no, if, does this even work? Yeah. Yeah, obviously we need to take something like negative 1 over 14 or something, and then it works out. Yeah, I think this was everything for the first part. Gonna erase everything, and then we are at the second part where they can use calculators and the stuff. Oh, hello there. You're still watching? That's great that you're still watching. It's about time I tell you about today's sponsor, Brilliant. We're kind enough to sponsor yet another video here on this channel. Parabolas, they're very nice. I really like parabolas. Maybe I've seen on the advent calendar that I covered a lot of parabola stuff, because there's much more to know about them than the eye meets at first sight. It's crazy how many visual things there are inside of parabolas that you don't even notice at first. But if you dig deeper into the whole topic of quadratic functions, you're going to notice that it's a seriously cool topic with a lot of applications in physics and also other parts of mathematics and also STEM. And this is where Brilliant could also come in with their huge number of interactive courses. They guide you through some of the most interesting and hard topics that you can find in STEM. Be it the mathematics that we did today, physics, computer science, chemistry. Really doesn't matter what you want to learn today, Brilliant is there for you to give you a hand and to ask you to use your hands to play around with their visualizations and their graphics inside of their courses. Their course system is absolutely amazing. They start off with, for example, parabolas, course on parabolas, functions in general. And you don't think much about it. You get the definition of a function and a bunch of different things. And then you probably see the graph at some point in time. And you're going to notice that they have little levers and the like, and little buttons that you can play around with. You can vary the parameters inside of a parabola or hyperbola or whatever the hell you want. And you're going to notice that you are going to get a better understanding of those very functions and other things too in STEM by using their visualizations and their absolutely amazing graphics. Varying parameters and the like. It's just a great visual way to represent functions and to see how they are basically performing under transformations. And it's giving you a really good understanding of what's actually going on if you do transformations on functions, for example. Or maybe you are into computer sciences and you just want to learn Python, for example, a tiny little bit. Then you can use their little blocks to basically program something in a matter of minutes, your first loop, your first little program. It's really just amazing. They have so much to offer, and I invite you to just check it out and try it out today. You can try it out for completely free, actually, for a 30-day free trial of amazing awesomeness by using my link down there at the top of the description, brilliant.org/ramblemess. If you think like this could turn into a long-term relationship between you and Brilliant, then do not fear. If you really make use of my link here down there in the description, you can actually get 20% of an annual premium subscription, which is an amazing deal. They have so much content to offer, and they are adding so much content on a regular basis. It's just wonderful. Also, Christmas is around the corner, so if you know someone who's interested in STEM and all things learning something new on a daily basis, then this might be the perfect Christmas present, a premium subscription for Brilliant. So check it out, support the channel this way, and you can also use my QR code somewhere up here to get right to my link here in your browser. And now back to the video, and I hope you did enjoy what you have seen up until now. Let's go. And I hope on part 1 everything was right, especially the inequalities. I haven't done inequalities in quite a while, but I'm hopefully still good at the game. Next up, part 2. First exercise, calculate the zeros of the following functions, those one. So the first one is, that's a classic, a. X squared plus 1, we must set it equal to 0, obviously doesn't have any real solutions. So this right here is not solvable. If we subtract 1 and take the square root, doesn't work out. Okay, next up we have 12x squared minus 3 must be equal to 0. Adding 3 on both sides and dividing by 12, we are going to get that x squared is equal to 3 over 12 or 1/4. 1/4. And now by taking the square root, we are going to get that x must be equal to, so x1 and 2 plus or minus 1/2 if we take the square root. Okay, good. And then we have for c 6/3 x squared must be equal to 0. Obviously, this is just a parent function, so it basically has its vertex in 0, 0, so the 0 of this thing must be equal to 0. So that means that x naught is equal to 0. That's an equivalence. It has a 0 with algebraic multiplicity of 2. And the last one then must be d, or h of x. Negative 8x squared plus 4x is equal to 0. And here I was basically just asking through all the different scenarios that you quite possibly can have, basically, apart from using the quadratic formula. Here, factor out an x, it makes the life easier. You can also use the quadratic formula, but it's just overkill. Factor out an x, so you get negative x plus 4 times x is equal to 0, and we now have two possibilities. Either x is equal to 0, x1 is equal to 0, or we are going to get negative 8x plus 4 must be equal to 0. We can solve this subtracting 4 and dividing by negative 8. We are going to get x is equal to 1/2. Okay, that was the first one. And number B, check which of the following points lie on which parabola from 1a. This is just a hassle. This is just for the people who don't know anything, and you can still plug in points and get yourself some points under the condition that you use parentheses in your calculator and the like. If not, then you are basically a bit wrecked. Get wrecked. This is number B. Okay, and the first point is 0, 0. Let us see which ones go through that. If we have, no, it doesn't go through this one, obviously. This one is centered at 0, so it definitely goes through e of x. And if we plug 0 into this one right here, it also goes through 0, 0. Negative 1 and 9, this obviously doesn't hold for this one. Negative 1 and 9 holds for this one. If like negative 1 and we get 12 minus 3 is 9. Doesn't hold for this one. No. And no, also not for the last one. Also doesn't work out. Then we have 2 and negative 4. Doesn't work for this one. If we have 2, no, this overtakes it. 6 over 3 is nothing other than 2. I'm going to rewrite this a tiny little bit. So 2 and no, doesn't work out here. The negative sign is missing. So then it's probably this one. If it fits into any of those. I'm not certain if all of those points fit into all or at least one of those. So if we have 2, then we are going to get 4. This right here is 4 times negative 8 is negative 32 plus, no, doesn't work out. So point number 3 doesn't go into any of those, I believe. 6 over 3, so 2 and 5. 2 and 5 works here, most definitely. It doesn't work here. Overshoots, it doesn't work, and here you are not going to get an odd number out, obviously, because those two factors are even. And 1/2 and 0, no, doesn't work here. That wouldn't work. 1/2 is a quarter. Overall, a quarter of 12 is 3. Works on here, on g of x. 1/2 and 0, no, doesn't work out here, obviously. And 1/2, that's a quarter, so we get negative 2, and here we get 2, so also on this one. So the last one works on those two. Okay, and that was number B. Yeah, I didn't write out the other points, but you have probably seen them on the screen. Next up, a monic parabola runs through the points 0 and -1, and also the point 1 and -1 determine the coordinates of its vertex. Alright, there are several ways to do this. It's a monic parabola, so the basically straightforward way you could do is you could say that f of x is equal to x squared plus px plus q, and then basically just plug in the points and solve. So if we have f of 0, then we get -1, and this is the same as q. So we have solved for q, so we have -1 here. And then we have 1 and -1. So f of 1 is also -1, and this is the same as 1 plus p minus 1. This and that is going to cancel out, so we get p is equal to -1, 2, negative x. And we need to find out where the vertex is. So what we can basically do is we can expand all of this a tiny little bit. We can use a binomial expansion here. Not a binomial, yeah, it's basically binomial expansion. Completing the square, that's what I was looking for. So we are going to rewrite this into, so we have 2 times 1/2 here basically. So we have x squared minus 2 times 1/2 x. So we need a 1/2 squared, but then subtract the ones again. So we need plus 1/4 minus 1/4, and then minus 1. This part right here is going to turn into x minus 1/2 squared. And this part right here is -5/4. So the vertex lies at 1/2 and -5/4. And it does make sense that it must be at 1/2, at least when it comes to the x, because both of our y coordinates for those points are at -1. So we basically have something like this here on the same height, and they are basically 1 apart in x direction. This one right here goes through 0 in the x direction, so goes right through the, not through the origin, but you know what I mean, right through the x-axis. And also it must be right here in the middle, since they have a distance of 1 to one another. We get 1/2 right as the x-coordinate. So the hardest part here is to find out what the y-coordinate must be for the vertex. Okay, now for the third one. Draw all the graphs of the following functions into a single coordinate system. Okay, so just a bit of context here. For students, it's kind of easy to draw those, because the only thing they really need to do is turn all of those into vertex form, or just think a tiny little bit when it comes to the zeros. And they have a parabola stencil. It's like a template where you have a normal parabola. It's a monic parabola, and all of those are monic. So they just need to find where the vertex is, or find 2 points to uniquely determine this monic parabola, and then they are good to go. For me, it's a bit harder because I don't have a real coordinate system here, and I also don't have a ruler. So I'm just going to eyeball this one. Okay, so the first one has its vertex at -1/2 and -2. So this right here is -1/2. This right here is -2. Just by scale, it's a monic parabola, looks like this, and it's opened at the top because there's no negative sign in front of our parentheses. Now the next one, g of x is equal to -x squared minus 3. That is a parabola that is open to the bottom. Also, we have it shifted 3 units into the negative y direction, and it's a monic parabola, so it's -3 here. So this right here is the next one. This is g, and this is f. Since they all draw it into one coordinate system, we have to basically number all of those a little bit. We have to name those. Next one, x squared plus 4x minus 1. Turning this into vertex form, x squared plus 4x minus 1. Same procedure as before. We are going to add 2 and subtract it once again, because this right here is basically just regular x plus 2 squared. Yeah, so this right here is x plus 2 squared. Minus 2 minus 1 is minus 3. So the vertex lies at -2 and negative 3. Negative 2 is somewhere here. Negative 3, we know where it is. It's open to the top, so it looks like this. Okay, this right here is E. And last but not least, we have h of x is equal to x squared minus 2x. Just like with this parabola here, we have it going through the origin, 0, 0, because we can factor out the x. And other than that, the vertex, x squared minus 2x, so we need to add a 1 and subtract it. So this right here gives us x minus 1 squared minus 1, so vertex lies at positive 1 and negative 1. So this right here is positive 1, this is negative 1, lies here, runs like this, and I think this should do the trick. Okay. Not nice looking, but I think it gets the point across, and we are all big boys here on this channel, so I think we can live with this crappy form that I'm having here. And now calculate the zeros of the functions. Okay, so this right here is the fun part. Let us start with the first one. We have x plus 1/2 squared minus 2 is equal to 0. Adding 2 on both sides, taking the square root, we are going to get that x12 plus 1/2 is equal to the square root of 2 plus or minus. Subtracting 1/2 on both sides, we are going to get that x1 and 2 is negative 1/2 plus minus square root of 2. Let me check if this fits. This right here is f. Oh, by the way, this right here was h. So it goes through nearly 1, okay, and nearly negative 2, something of the sort. Okay, next up, doesn't have any zeros. If you take a look at the sketch right here, doesn't have any, but we have to check. We need to calculate the zeros. So negative x squared minus 3 is equal to 0. This gives us that x squared must be equal to negative 3. Doesn't work out. No real solutions here. Now for the next one, we already put it into vertex form up here. So if I'm going to set it equal to 0, we are going to subtract 3 and take the square root. So we are going to get that x12 plus 2 is equal to plus or minus the square root of 3. And now we are going to subtract 2, giving us overall that x12 is negative 2 plus or minus the square root of 3. And the last one, x squared minus 2x is equal to 0. So we are going to get that either x1 is equal to 0, just as I mentioned before. I'm sorry about that. And the next one we would also have, if we were to factor this into linear factors, x times x minus 2. And the other one must be equal to 2, right? Yeah. Should fit the bill right here. Yeah, vertex was at 1. Obviously, I wouldn't even need to have to calculate anything. Just works out. So the x2 is x2 is equal to 2. Okay, nice. So we have calculated all of those. And now for the last one. The students, I didn't write it here on this paper, but the students were able to choose one of those basically text questions. And after raising everything, I'm going to solve both because I'm the teacher. All right, gotta solve both. Parabola text questions are actually some of my most favorite text questions in school because they are just so relatable when it comes to physics situations and the like, so they are pretty cool. So the first one is shot put, okay, where you take a big old mass and you shoot it. Shot put is an Olympic discipline where heavy balls are thrown in such a way that the thrown distance is maximized. Obviously, we want to throw hard and we want to throw wide. The trajectory of the ball is parabolic, as shown in the graph below. You can see the graph right here. The ball leaves the hand of the athlete at a height of 2 meters above the ground and reaches a maximum height of 6 meters, exactly 4 meters horizontally away from the thrower. How far has the athlete thrown the ball? Calculate the distance in meters. Let us draw the sketch out once again, and let's go through all of the text and see what we can get. So he shoots it at a height of 2 meters. It starts at a y-intercept of 2. Next up, after 4 meters horizontally, so this is here, he is going to have to the ball a height of 6 meters exactly. 6 meters is here. So basically what this just means in calculus terms is that we have our vertex right at 4 and 6. And we know that this right here is a parabola. Also, what we basically do is, do we think of it as a monic parabola? I'm not certain about that anymore. We need to see. I mean, we also have the y-intercept given, so I think no, this is not a monic parabola. Not exactly. Let us see. So the first thing we are going to do is we are going to say f of x is not a monic parabola, so it has an a in the front as a stretching factor, but we know where the vertex is. It's at x minus 4 squared, and then we have plus 6. Now we also know the y-intercept of all of those. So meaning we can find out with another point that we know what a is, and the point is a different one than our vertex point. So that's nice, I guess. Not an equivalence. That's just an implication. If we plug in our coordinates, so we are going to get f of 0 is hence 2. And this is equal to a times, if we plug 0 into here, we are going to get 4 squared. This is 16, so we are going to get 16a plus 6. Yeah, our a is non-unity. It's not a unit. So we are going to subtract 6 on both sides. We are going to get 60. No, obviously it's not monic. It's open to the bottom. Obviously, that is stupid. I'm terribly sorry about it. So 16a is equal to negative 4. Dividing by 16, we are going to get that a is negative a quarter. Okay, nice. This right here is our equation. How far has the athlete thrown the ball? Calculate the distance in meters. What does it mean? Take a look at the text once again. Throwing the ball means we need to find our 0 of the function. So setting all of this equal to 0, what are we going to get? At first, subtracting 6 on both sides and multiplying by negative 4, we are going to get that 24 is equal to x minus 4 squared. Yeah. And then we're going to take the square root. We are going to get that x12 minus 4 is equal to roughly 5, you could say, plus or minus the square root of 24. That is roughly 5. Okay, just for the sake of the video, we are going to say that this is roughly plus or minus 5 or 4.9, something of that form. So we are going to add 4 on both sides. We are going to get that x12 is hence equal to plus or minus 5 plus 4. Roughly. Okay, just very roughly. I don't have a calculator right now. It's something in the vicinity of probably 4.95. Only one of those solutions makes sense. The negative solution doesn't make any sense because he's not throwing the ball to the back. I mean, in certain contexts, it could make sense if he tries to throw and it slips, but it doesn't make here. He's throwing it to the front, so we need to take the positive branch. And for a bit more viewer satisfaction, we are going to say that this is 4.95, something of the sort, so it lands at 8.95 meters roughly. I hope this checks out. Calculate the distance from the thrower for which the ball thrown has a height of 0.75 meters. So what we need to do is we need to think in the coordinate system, what is the height? Well, it's basically the y coordinate. This right here is roughly 0.75. So we need to find out where our function has a value of 0.75 basically as the y coordinate, and we need to solve all of this for x. So if we plug it in, we are going to get that just the x coordinate of that. Yeah, right. Okay, so 0.75 is the same as 3/4 is equal to negative 1/4 x minus 4 squared plus 6. Let's get rid of the 4 right here. So multiplying everything by negative 4, we are going to get that negative 3 is equal to x minus 4 squared and negative 24. Subtracting, adding 24 on both sides, we are going to get 21 is equal to x minus 4 squared. And yeah, I mean, it does make sense. The x-coordinate must be in front of the 24, just dimensionally speaking. So by taking the square root and adding 4, we're going to get that x12 is equal to 4 plus or minus the square root of 21. Square root of 21, something in the vicinity of, it's basically a bit more than half the way from 4 to 5. So I would point my finger on 4.59. 4.59. So this right here is at 4 plus or minus 4.59. But the negative one doesn't make any sense. So it's roughly at 8.59 meters. Okay, and that's basically it. And now we have a bridge given. I hope everything was correct. We have a bridge given, and the bridge has a parabolic arch with the following properties. The arch is stretched in x direction by a factor of 0.01 meters. So it's basically shrunk in the y direction, so stretched in the x direction, and is opened at the bottom. So it looks something like this. This right here is a very, very wide buoy. And the bridge's arch emerges from the street after 10 meters and touches the ground again after 80 meters. It's hard to formulate something like this if you don't want to really point to draw a coordinate system and do so. So it's a bit of imagination work. So what that just means, if our coordinate system looks like this, then our bridge basically starts at 10 right here and ends at 80. So those are basically the zeros of our function. And this right here is a very cool exercise, and this is not often taught anymore in Germany because now you know the zeros of the function, meaning what we can basically do is we can use the sectorized form, construct the equation describing the shape of the bridge. Yeah, that's actually the first exercise. So for A, we are going to have that f of x is equal to stretching factor of 0.01 and with a negative sign at the very front because it's open to the bottom. And we know what the zeros are. They are at first at 10. So x minus 10 is the first linear factor, and the other one is x minus 80. And this right here is the equation, and I can remember this one because it just got stuck in my head because no one got it right. No one got this equation right. So this just went terrible. Students just couldn't figure this out with the factorized form for whatever reason. We have practiced it time and time again, but what can you do? Calculate the highest point that the bridge can reach. Obviously, we need to find the vertex point, and it's in between 10 and 80, so the x-coordinate must definitely be a distance of 70 meters, so at 45. This is something that we definitely need, but we also need the y-coordinate. This is what we need to figure out. So the first thing that we are going to do is we are going to multiply the factorized form out, but the stretching factor, we can leave it on the outside and multiply it in later. So what we get is that f of x is equal to negative 0.01 times, okay, here we are going to get x squared. We are going to get negative 90x, and we are going to get plus 800. Okay. Putting this into the vertex form, we are going to get negative 0.01 times 90 is 2 times 45. So we need to add a 45 squared, and we need to subtract this. Ugh, fuck my life. Gotta calculate 45 squared. But overall, what we are going to get, and this is not surprising at all because of our analysis that we did here, gotta get rid of this. For now, we are going to get x minus 45 squared, and then we are going to get negative 45 squared plus 800. Okay, and all of this times negative 0.01. So let's calculate negative 45 squared at first. 45 squared, so this is 40 times 40, so we are going to get 1600. We also get 5 times 40, this is an additional 200. File. No, I'm being stupid right now. Why am I factoring out it so much? I don't know. Sorry, has been a very, very long week trying to get my shit together here. Okay, no calculator allowed. I don't even have a calculator, so I couldn't even use one if I had one. So let's get this straight. So 45 squared, that's 45 times 45, 40 times 45, 4 times 45. This is going to give you 160, 180, so this is 1,800. 5 times 45 is going to give you 200, 225, meaning this overall is, if we have a negative sign at the front, so getting rid of this, we are going to get negative 1,225. So all of this times 0.01, we are going to get negative 0.01 times x minus 45 squared. And then we are going to get negative, and negative is positive, obviously must be positive. And all of this at 12.25. So this right here has 12.25 meters in height. And I think, I hope I calculate everything correctly. Draw the graph of the function. I mean, yeah, this already does it. As far as the graph goes, here we had points given and we can just connect those, and that's totally fine. And for the sake of the text question, they basically just need to draw this upper part above the x-axis. Well, I mean, for ninth graders, that was probably really hard, and I'm kind of sorry for that, because those were kind of a lot of things they had to remember. But what can you do? Okay. I was new. I tried my best to make it as weit gefächert, okay, many topics in there as possible. And I think, as far as the exam in itself is concerned, it's kind of a cool exam, because there are a lot of questions from many topics in here. But tell me down there in the comments what you thought about this exam. Was it too hard? Was it too easy? Tell me your opinions down below. Yeah, but that's about it. Not many more videos to go for the advent calendar. So yeah, stay tuned for the last ones. Thank you guys for watching. Wish you guys a favorable day. See ya.